Hi, I am going to discuss about the very important things in deep learning, that is the loss function and as well as the cost function. Actually, in case of ANN has two problems. One is regression as well as one is the classification. Similar things we have done in machine learning. In case of regression, the output value is the continuous, okay, and in case of the regression there is three loss function. What is loss function? Loss function is the loss means the actual value minus the predicted value. Using backpropagation, our main aim to minimize the error, okay. Here three types of loss function: mean squared error, mean absolute error, and the Huber loss. Even I did not use Huber loss in any deep learning problem. I have only used MAE, that is mean absolute error, and mean squared error. Okay. And what is the cost function and what is the loss function? Cost function means batch of data point we will pass in case of cost function, and loss function means one single record we will pass in loss function. And the formula of mean squared error is half of y actual value minus predicted value. And the cost function, it is same, and here I will use I equal to 1 to n. I equal to 1 to n. I think it is clear. And this is the formula of the loss and cost function in mean squared error. There is also advantage and disadvantage. Each and every things, its pros and cons. Okay. Here the advantage is it is basically differentiable and there is one global minimum, and our main aim to reach the global, there is one global minimum. Okay, and it converts faster. It does not take so many times to converging. It converts faster. But there is main issue in when outlier came into picture. When outlier came into picture, that time it penalizing the error because square the square something, my outlier is 4, and the formula of the loss and cost function, both cases y minus y hat square, that's why it penalizing the error. 4 into 4 are 16. Error will increase, it penalizing the error. It is the main disadvantage of the mean squared error. That problem will solve the another cost function and loss function, that is the mean absolute error. Mean absolute error, actually the formula of mean absolute error is half summation of y minus y hat. And in case of the cost function, half I equal to 1 to n, half summation of I equal to 1 to n, y minus y hat. Actually, in case of the mean absolute error, when outlier came into picture, it actually handled the outlier because it did not penalizing the error. Okay, and here is also disadvantage. The graph of the mean absolute error is it takes actually time because it calculates gradient, subgradient wise. One data pass. It takes time. Overall process will done in that case, that part, and then another process will happen. It takes time. It actually pass the overall things using subgradient concept. That's why it takes time. There is the main agenda of these things and Hubbard. Hubbard is actually the combination of the mean squared error and the mean absolute error. When outlier is not into picture in that point of time, the formula of the formula of Hubbard loss is the half of y minus y hat square. When outlier came into picture, the formula will be changed. And there is a concept of the uh, delta, the formula of the delta y minus y hat square, sorry, not square, y minus y hat, mode of y minus y hat minus half of delta square. I never use Hubbard loss. I have used only the mean squared error and the mean absolute error. That's all for today's video.